About 8 billion light-years from Earth, two galaxies hit each other head-on. What's left of them is staring back at us. Two glowing rings. A black hole burning at the center of each one. A bright streak of gas between them. It looks like an owl, or, depending on how you tilt your head, an infinity sign. This is one of 5 objects astronomers have found in the last 2 years that nobody can fully explain. Some appear to have formed faster than current models allow. Some don't fit any category we already recognize. One of them is the largest structure ever measured. Chapter 1. The 44-minute pulse. Pulsars rotate fast. Most spin once every few seconds. The fastest tick over 700 times a second. There's a reason for this. To produce the radio waves we detect, a neutron star needs to spin quickly enough to power its magnetic field. Slow it down, and the lights go out. In 2024, a radio array in Western Australia caught something that breaks the rule. ASKAP J1832-0911 emits a 2-minute burst of radio waves, then goes quiet for 42 minutes, then pulses again. That's slower than any standard model of pulsar emission predicts. But here's the part nobody has an explanation for. It also pulses in X-rays, perfectly synchronized with the radio bursts. It's the first long-period transient ever caught doing both at once. Every leading theory has a problem. Standard magnetar models predict that objects rotating this slowly should have gone dark long ago. A white dwarf binary doesn't quite fit the X-ray signature. A precessing intermediate mass black hole has been proposed, but hasn't been confirmed. Whatever this object is, we don't have a category for it yet. Chapter 2. The Cosmic Owl. 8 billion years ago, long before the sun had ignited, long before the Earth had cooled enough to bear oceans, those two galaxies collided. Not a glancing blow, a direct, head-on impact. In June 2025, 2 independent teams of astronomers, one at Tsinghua University, one at Yale, both pulled the same unusual object out of public JWST data within a single week of each other. Neither knew the other had found it. The Tsinghua group called it the Cosmic Owl. The Yale group called it the Infinity Galaxy. Same system, 2 papers, 2 names. Here's what they found. 2 ring galaxies, almost identical in size, that collided face-on roughly 50 million years before the light we're seeing left them. Ring galaxies are already rare. They form when a smaller galaxy punches straight through the disk of a larger one, sending a shockwave outward that lights up a circle of new stars. Finding 2 of similar mass colliding head-on, almost perfectly aligned, is exceedingly rare. Each galaxy has a supermassive black hole at its center. Those are the eyes of the owl. What isn't supposed to be there is the third one. Between the 2 galactic cores, embedded in a vast cloud of compressed gas, sits a third black hole, about 1 million times the mass of the Sun. Supermassive black holes are almost always anchored at the center of their host galaxy. This one isn't sitting in any galaxy at all. The leading interpretation is that it formed there, not from a dying star, but from the gas itself. The gas crushed at the collision front, collapsing under its own gravity in a single event, skipping the stellar stage entirely. A direct collapse black hole. Theorists have been predicting these for over a decade. This might be the first time we've caught one mid-formation. If that's right, it could explain something else JWST has been finding all over the early universe. Chapter 3. The Little Red Dots. When JWST started imaging the deep universe, it found something nobody had predicted. Hundreds of tiny red dots scattered through the sky, mostly from the first 1.5 billion years after the Big Bang. They're remarkably compact. Each one packs the light of hundreds of billions of suns into a region smaller than a single galaxy. The spectra are stranger still. Some look like populations of ancient stars. Some look like feeding supermassive black holes. And some look like both at the same time. Nobody knows what they are. They might be a stage of galaxy formation we never anticipated. They might be black holes growing far faster than physics says they should. Or, coming back to the infinity galaxy, they might be direct collapse black holes caught at their earliest stage. If supermassive black holes can form straight from collapsing gas, instead of waiting for stellar deaths to seed them, that would solve a problem that's been bothering astronomers since JWST turned on. How the universe already had fully grown supermassive black holes less than 1 billion years after the Big Bang. The little red dots might be the answer to that question. Chapter 4. The Big Wheel.
The early universe was supposed to be a mess. Small, lumpy proto-galaxies crashing into each other, slowly stacking up over billions of years into the mature spirals we see around us today. Then, JWST found the Big Wheel, a fully formed, rotating disk galaxy, 5 times more massive than the Milky Way when the universe was only 2 billion years old. Its spiral arms are well defined. Its rotation curve looks like that of a galaxy already in middle age. Standard models predict galaxies this large shouldn't form this early. Its disk is about 3 times bigger than current cosmological simulations allow for at that cosmic epoch. The explanation the Discovery team favors is that the Big Wheel sits in an exceptionally dense pocket of the early universe, a region where galaxy number density is more than 10 times the cosmic average. In that kind of environment, it would have had access to gas-rich neighbors and frequent non-destructive mergers, both of which could have fed its growth. Either way, it's a galaxy we'd expect to find 5 billion years later, not 2. Chapter 5. Quipu. In early 2025, astronomers mapping the local universe announced the largest single structure ever identified in the cosmos, a chain of galaxy clusters 1.4 billion light-years long, containing the mass of 200 quadrillion suns. They named it Quipu, after the knotted cords the Inca used to record numbers. A tally string, a record written in galaxies. Here's why that matters. The standard model of cosmology predicts that above scales of roughly 1 billion light-years, the universe should look smooth. Matter should be more or less evenly distributed in every direction. It's called the cosmological principle, and most of modern physics is built on top of it. Quipu sits above that threshold. So do the Sloan Great Wall, the Hercules Corona Borealis Great Wall, and the Giant Arc, a growing list of megastructures that push against the limit of what the standard model is supposed to allow. It doesn't break cosmology by itself, but it does suggest that either our simulations of large-scale structure formation need adjusting, or our definition of smooth needs to grow. 5 years ago, almost none of these objects had been seen. The universe did not change, only our eyes did. JWST sees deeper than any telescope before it. Vera Rubin sees wider. ALMA sees colder. ASKAP listens longer. Each new instrument opens a new window onto a cosmos we thought we had begun to map. And through each new window, the same quiet truth keeps returning. The universe is older than we imagined, stranger than we imagined, more crowded with mysteries than any previous generation could have dreamed. The strangest objects in the cosmos are not the ones we have already found. They are the ones still waiting.